So in this video today, guys, we're going to go over the quiz 2 review, okay, and practice. So for number 1 here, I would suggest that you guys try to write these out before you look at this and then see what you didn't write down so you know what to memorize. So diagonals have the same midpoint for parallelograms and opposite sides are parallel and congruent. Rectangle diagonals are congruent. And all this diagonal stuff is what you need to the new stuff that you need to memorize for this quiz. Consecutive sides are perpendicular, opposite sides are congruent for a rectangular. And then rhombus, diagonals are perpendicular. Obviously, all sides are congruent in a rhombus. And then down here, for a square, diagonals are congruent and perpendicular. For right angles, a square has and all sides are congruent. And then with a right triangle, a pair of sides are perpendicular, okay? So number 2 says create equations of lines that are parallel to the given equation. So what we're going to do is we're going to take this equation, negative 6x minus 4y equals 32, and we're going to put it in y is equal to format. So we're going to get everything but y on the other side of the equal sign. So for this, we're going to add 6x to both sides. And we cannot combine 6x with 32 because it's not a like term. Okay, so now it's gone from there, and we get our negative 4y equals 6x plus 32. Hopefully you recall that what negative 4 and the y being next to each other means they're being multiplied, and the opposite operation of multiplication is division. So we're going to divide both sides by negative 4 here. So the negative 4's are gone, so we got y is equal to, and remember, if we divide a positive by a negative, or vice versa, we're going to get a negative number. So this is going to be negative. And what are both 6 and 4 divisible by? 2, right? So we're going to divide them both by 2 to reduce this, okay? And that's going to be our x. And then again, if I divide a positive by a negative or a negative by a positive, we get a negative number. So that is 4 goes into 32 8 times, okay? So what are we interested in here if it's saying that this is parallel? We're interested in our slope, right? Okay, so remember our equation, y equals mx plus b, right? And our m is our slope, yes? The m right here is our slope. So what is it? What is the coefficient that's in front of the x? It's right there. You see it? So that's what we're interested in if we want to write an equation that is parallel. So this, if we write an equation that's parallel, y is equal to negative 3 halves x. And we really could say plus or minus any number we want, right? So any number could be here, okay? Could be a big number, could be a small number, doesn't matter. All right, now it says also then write them in standard form. So to write things in standard form, it means we're moving everything except for the constant to the left side of the equal sign, okay? So let's just say we had put a 0 here, plus 0, okay? So if we've done that, then we're going to move this 3 halves to the other side. So we're going to add 3 halves to both sides, right? 3 halves x, okay? So now this is going to be 3 halves x plus y equals 0. So our constant would end up on the right side of the equal sign and everything else would be on the left. All right, for number 3, it says given the following equations in standard form, classify them as parallel, perpendicular, and either. So once again, what do we want to do here? We want to get these equations in y is equal to mx plus b format, and we want to compare the m's, okay? So we're going to do this with both equations. So I'm going to subtract x from both sides here. So that's going to give me 11y is equal to negative x plus 12. Then I'm going to divide everything by 11. Now hopefully you know there's a 1 up there in front of that x, right? So this is going to be now our y's just by itself, right? So this is going to be negative 1 over 11x plus our 12 over 11. And we're going to compare that m right there to the m we get in the other equation, okay? So we're going to do the other equation. This time we're going to add 11x to both sides. So this one is going to be y is equal to 11x minus 44. So once again, we're comparing our slopes, right? So there's the slope of the other one. So we got a slope of negative 1/11, and we got a slope of 11. So what is the relationship between those slopes? One's positive, one's negative, and aren't they the reciprocals of each other? Because 11 is 11 over 1, isn't it? Okay, so that means these are perpendicular, right? And they are perpendicular, again, because they are not the same sign, and they're reciprocals of each other, or they're flipped. All right, let's do this next one. Same thing, okay? You might want to pause the video, do it yourself, and come back to me when you're done. So here again, we're going to subtract the 6x from both sides. So now it's gone from there. We got negative 4y is equal to negative 6x plus 12. Divide everything by negative 4. Now, the 4's are gone from over there. We got y is equal to, here again, we got a negative over a negative. Remember, that's a positive. And both 6 and 4 are divisible by what number? 2. So this is going to end up being 3/2 x. And when we divide a positive by a negative, we get a negative, and 4 goes into 12 3 times. Going to do the same thing with the other equation. So once again, we're going to add 3x to both sides, right? So 2y equals 3x plus 10. Divide everything by 2. So the 2's gone from there. So y is equal to 3/2 x plus 5. And once again, what are we comparing? Our slopes. Y'all see that right there? Our m's. That means the coefficient that's in front of the x. These are the same. Do you notice that? So that means they are parallel, because that is what parallel means, that the slopes are the same. Okay? All right, once again, you may want to pause the video, do this next one yourself, and then come back to me. Going to subtract 4x here, going to subtract 4x here. 3y, it's now gone, equals negative 4x plus 18. Divide this by 3, that by 3, and that by 3. Our 3's are gone there, so this is y is equal to, again, remember, you divide a negative by a positive, you get a negative. Negative 4/3 x, and that's plus 6. Here we're going to add 2x to both sides. So this is going to be y is equal to 2x. Sorry, we're supposed to add it to both sides. Minus 3. Okay, so once again, what are we comparing? We're comparing our slope here with our slope there. And those have no relationship, right? They're not reciprocals of each other for sure, and they're not the same number. So this is neither. Okay? All right, with number 4, it says several streets in downtown Atlanta are parallel. Key phrase. These include Auburn Avenue and Edgewood Avenue. The equation for Auburn Avenue is negative 4x plus 3y equals 36. If Edgewood Avenue goes through the point 39, what is the equation for Edgewood Avenue? So we're trying to find an equation. So what we want to do with this equation first is put it in y is equal to format again. So I'm going to add 4x to both sides so that that's now gone. So that's going to give me 3y equals 4x plus 36. Divide everything by 3. So y is equal to 4/3 x plus 12. Now, we're going to use our equation, y equals mx plus b, and we're going to substitute in everything we have. We have our m right here, right? That's 4/3. We have our x there and our y there. So we're going to substitute these in, and we're going to solve for b. So we've got, sorry, my screen went crazy. So we're going to go back here and start this again. So again, my y, we're putting this in y is equal to mx plus b format. So my y is 9. My m is right there, so 4/3. There's my x times 3 plus b. I'll teach y'all a little hack here, okay? Let's make this 3/1. Wow, it happened again. Hold on. So if I make that 3 a 3/1, then here's your hack, y'all. Don't these 3's are on the numerator and the denominator cancel out? So we're just left with 4 over here, right? Equals 9 plus b. How do we get rid of the 4? We subtract 4 from both sides. So b is equal to 5, okay? So now we plug back in this b with that m into our equation y equals mx plus b. So y is going to be equal to, what's our m? 4/3 x plus our 5, which is our b. Okay, given the following endpoints for the line segment, identify the midpoint for each segment, okay? So now I asked my kids, because we've talked about this for days now, how would they describe how to do this problem? And they said they would add the x's together and divide by 2 for the x midpoint. And they would add the y's together and divide by 2 for the y midpoint. So what are our x's here? Right there. So we're going to go negative 2 plus 7 divided by 2. That's 5 divided by 2, which is 2.5, right? Then we're going to add our y's. Here's our y's. This is 6 plus 10 divided by 2. That's 16 divided by 2. So that's 8. So our point is 2.5 comma 8. Do the same thing with the next one. So once again, we're going to do 12 plus 0 divided by 2. That's 12 divided by 2. So that's 6. And then for our y's, we're going to do 0 plus 3 divided by 2. 3 divided by 2 is 1.5, right? So our point is going to be 6 comma 1.5. That's our midpoint. So for this next one, it says find the midpoint of EX. So I'm going to find out what E is right up here. So my X value is 2.5. So E is 2.5 and my Y value is 3.5. I'm going to go ahead and do X as well. This is not my day, y'all. So my X is going to be, again, 3.5. That's my X value. And my Y value is 3.5 as well. And then my T is going to be 3.5 and then 0, right? So now we're going to find the midpoint of EX. So we want our X values here. So here are X values of E. 2.5 plus 3.5 divided by 2. That's going to be 6 divided by 2, which is 3. Then we're going to find our, let's pick a different color here, our Y values right there. So we're going to add 3.5 plus 3.5. That's divided by 2. That's 7 divided by 2, which is 3.5. And by the way, anytime you have the same point, it's going to be that point. So this is 3.5. That's the midpoint of EX. We're going to do the same thing for the XT. So here we go again. So the X value of the X in the T is the same. 3.5 plus 3.5 divided by 2. That's the same one we just got a second ago, so you guys should be able to see that pretty quick. Now we're going to do, again, our Y values. You see them right here? So we're going to go 3.5 plus 0 divided by 2. That's 3.5 divided by 2. Do that in your calculator. That's 1.75. So the midpoint of this one is 3.5 comma 1.75. All right, so the next one, this is the formula y'all learned. I'm going to show it to you over here on the left. XM is equal to X1 plus X2 divided by 2. YM is equal to Y1 plus Y2 divided by 2. Now, one of my students came up with a great hack, and I'm going to show you it. So, and I want to show you why. So if I multiply both sides of this by 2, now my 2's gone from there. Y'all see that? So that means I would do 2 times my midpoint, and that's going to be equal to our 2 x's added together, right? Same way down here, same thing. So this will be 2 times my y midpoint, and that would be equal to my 2 y's added together, okay? So let's see how that works with this particular problem. So if I take my midpoint, and you got to read this, guys, because it says the midpoint of the line segment is -6 comma 4. One of the endpoints is 1, 2. Find the other endpoint. Find the other endpoint. This is not asking us to find the midpoint this time, okay? It's asking us to find the other endpoint. So what we can do with this value right here, our midpoints, is multiply them by 2. Isn't that what we said right here? 2. Okay, so that's going to be 2 times -6. And that's going to be equal to x plus r1. See that? And the other one is going to be 2 times 4. 2 times 4. That's going to be equal to what? And some of y'all can do this in your head, I have no doubt. This is going to be y plus r2 right there. See that? So that's going to be what? -12. Actually, let me do this in blue, just so I can keep my color scheme here. So this is going to be -12 is equal to x plus 1. So we subtract 1 from both sides here. So that means x is going to be equal to -13, right? This other one's going to be 8 here. So 8 is equal to y plus 2. We subtract 2 from both sides. So y is equal to 6. So my end point here is -13 comma 6. So let's do this with the next one. Aren't we just going to now multiply this by 2? So 2 times 2 is 4. 2 times 6 is 12. This is going to be equal to x plus 3. This is going to be equal to y plus 8. Now, how do we solve it? We subtract 3 from both sides here, right? So x is equal to 1. We subtract 8 from both sides here. So y is equal to 4. So my point here was 1, 4. Same thing with the next one. I'm going to multiply both of these by 2. So that's going to be negative 6 and 6. That's equal to x minus 4 and y plus 3. Add 4 to both sides. So this is going to be what? Negative 6 plus 4 equals x. So x is going to be equal to negative 2, right? The other one is going to be 6 minus 3 equals y. So y is going to be equal to 3. So my ordered pair here is going to be negative 2, 3. All right, number 8 says find the equation of the line that is parallel to y equals negative 3x minus 4 and passes through the point negative 2, 1. Okay? So we want to find our slope. M equals negative 3. And if it's parallel, it's the same slope. This is going to be my x and my y. Told you it wasn't my day. X and y. So here again, we're going to put them in the equation. Y equals mx plus b. We have our m right here. We have our x right there. We have our y right there. We're going to substitute them in. So our y is 1. Our m is negative 3. Our x is negative 2. And then we're solving for b, right? So negative times a negative is a positive. So this is going to be y is equal to 6 plus b. We're going to subtract 6 from both sides. So our b is going to be equal to negative 5. Now remember, we are going to substitute in our m and our b in that equation. And our equation for the line is going to have y and x in it. So y is equal to negative 3, that's our m, x minus 5. So what's the difference between this and the next one, y'all? What word? Perpendicular, right? So we got the same line. So what is the perpendicular slope to that? What's the perpendicular slope? Perpendicular slope to negative 3. Perpendicular m would be positive, and what's the reciprocal of 3? 1/3, okay? So remember again, our x and our y are over here. So we're using our equation y equals, so that's 1 equals, our new m, see our new m, don't forget this, 1/3 times our x, which is negative 2, plus our b, okay? So now here again, remember, this is negative 2 over 1. So we're going to multiply across the top and across the bottom. So this is going to be 1 is equal to negative 2/3 plus b. Now how do we combine this? Hopefully you remember you give them common denominators. So this is 3 over 3. Now I'm going to add that 2/3 to it because I'm getting rid of it from the other side. So what is that going to give me? What is 3 plus 2? 5, right? So this is going to be 5/3 is equal to b. And we're going to substitute in now our m and our b. So there's our b, there's our m, right? So our equation is going to be y is equal to, what's our m? Our new m, 1/3 x, right? And our new b is plus 5/3. All right, so the next one says, determine if the quadrilateral below are parallelogram, rectangle, rhombus, or square, and justify your answers. If possible, use 4 different colors to draw them. So I'm going to do the first one in red because I did the T and the U in red. And you should have changed these numbers on your review because they were definitely not correct on the original review. So I already plotted R and S, sort of. Kind of moved a little bit. Let me see if I can fix it so it's actually where it's supposed to be, right there. Okay. All right, so there's RS. And so I'm going to plot T and U. R and S are the same for all 4 problems. So we're going to start there. So we only have to plot 2 points for each. So 5, 4, 5, 4 is right there. And that's my T. And then I got U at 2, 5 right there. So now I'm just going to connect my dots, right? So when we talked about shapes, I want you guys to look at this. And what would you predict this would be? There's 2 shapes that we know for sure it's not, right? Rectangle and a square, right? So it's either a parallelogram or a rhombus. So let's determine which it is, okay? So I'm going to use the diagonals here because I think that that's the easiest way to do this. So I got a vertical diagonal right there, US. And I've got a perfectly horizontal diagonal right there. Y'all see that? So what can you tell me? Can't you tell me those are perpendicular? So we're going to say US is perpendicular to RT. And that is the only property I need to prove that this is a what? Rhombus, right? Okay, because that is a property of the rhombus. All right, so the next one I'm going to do in blue. Okay, so the next one we're going to do V and W. Okay, so V is at 0, -3, right there. That's our V. Our W is at -3, -2. So that's our W right there. So once again, we're going to connect these dots with our black lines. And what shape does that look like it is? That looks like it's a rectangle, doesn't it? So what was the property about a rectangle? The quickest way to prove that this is a rectangle is to say that the diagonals are congruent, right? Okay, so everybody look up here. So I'm going to look at RV first. Okay, so let's look at RV. We're going to find out how long RV is because that's the length of it. So we're going to count down. Sorry, that was RV right there. 1, 2, 3, 4, 5, 6. Wait, no, I didn't count. Sorry. 1, 2, 3, 4, 5, 6, 7. So that's one of my 7 squared. And then how far over? 1, right? Plus our 1 squared. So 7 squared is 49. 1 squared is 1. So this is going to be the square root of 50. And what we want to do is compare it with the other one, okay? So now we're going to compare it with WS right here. Okay? So we're going to look at the length of WS. So with WS, I'm going up 1, 2, 3, 4, 5, and over. I don't know how that just moved, but 1, 2, 3, 4, 5, and over 1, 2, 3, 4, 5. Something moved, y'all. What in the world is going on here? So either way, we counted 5 up, right? 5 squared plus 5 squared. That's 25 plus 25, which I think all of y'all know is 50. So what did we just prove about the diagonals? They're the same length, right? So we can say RV is equal to WS, so this is a rectangle. Okay, the next one we're going to do in green. So again, we already have RS on there, so we're going to look at X and Y. So this is going to be -1, 0. -1, 0 is right there. That's X. And then we have Y, -4, 1. There's our Y. Okay, so we're drawing these up to that RS. So what do you notice about this one? What two shapes do you know for sure it's not? Rectangle and square, right? Okay, so it's either a parallelogram or it's a rhombus, right? So I'm just going to count the rise over the run of these two sides. So I'm looking at YR right here. Y'all see YR right here? YR? So I'm going to go 1, 2, 3, 1, 2, 3. So if I look at YR, that's going to be 3 squared plus 3 squared, right? So that's 9 plus 9, so that's the square root of 18. So for it to be a rhombus, then RS would have to be the same, right? The same two numbers. So let's count RS. 1, 2, 3, and 1 down. So RS is 3 squared plus 1 squared. Well, that's 9 plus 1, which is square root of 10. So these are not equal, are they? So that would cause us to say that this is absolutely a parallelogram. Okay. Now remember, our properties of a parallelogram with respect to the diagonals are that they have the same midpoint, which again we could find, and on this one is actually, right there's our midpoint, isn't it, of Rx, because it's 2 down and 2 up. We would just have to find the other one to make sure it was the same midpoint, okay? So we got one more. We're going to go purple here for our last one, and this was, we changed this to 1, 0, y'all, okay? So again, we still have our RS, so we're going to go 1, 0. That's our P, and then we're going to go Q, -2, 1. -2, 1 is right there. There's our Q. So If we connect these, what shape do y'all think that is? Looks like a square to me too, but let's check. Okay, so we're going to do our diagonals again, okay? And we're going to find if they are the same, not QP, sorry, we're going to do our diagonals. So we're going to do QS and what? RP, okay? RP. So if we look at QS right here, let's go up 1, 2, 3, no, 1, 2, sorry, 1, 2. Oh. Okay, so again, if I talk about QS, so I'm going 2 up, 1, 2, yeah, where am I at? So here's QS, y'all. So I'm going up 1, 2, over 1, 2, 3, 4. Got that? So this is equal to 2 squared plus 4 squared, which would be what? 4 plus 16, that's the square root of 20. Okay, and then let's talk about the rise and run of this. Is it rising or falling from left to right? So we're going to talk about the slope, okay? So we know it's positive because it's going up from left to right. And we went up how far? Did we go up 2 and over 4? So this is going to be 2 over 4, so that's going to be 1/2, okay? Now let's talk about the other one, RP, right here. There's our RP. Y'all got it? What's happening to it? Falling, yeah. So when we get there, we will talk about that, okay? So we're going to go from R to P. So I'm going down 1. Here, let me do this in black so y'all can see it better. 1, 2, 3, 4, and over 1, 2. Y'all see that? So on this one, again, we went 4 down and 2 over again. So if those are the same two numbers, we know this has to be the square root of 20. So right now we could say QS is equal to RP, right? That's one of our conditions for this to be a square. The other one is we have to determine if the slopes are perpendicular, right? So once again, what was that line, RP, here's our RP again, y'all, right there. Is it rising or falling from left to right? We talked about this already. So M is going to be negative, right? It's falling. And we went down 4 and over 2, didn't we? So that's going to be -2. So what is the relationship between these two slopes? You got it. They're perpendicular. So we're going to say QS is perpendicular with RP. And because these diagonals are both congruent and perpendicular, we can say this is a square. Again, know your properties, guys, because on this quiz, you're going to have to justify your answers, okay? All right, so for this next one, it says, given the following points on the graph, A, B, C, if we want to create a figure ABCD into a parallelogram, then what should the coordinate for D be, okay? Or B for D. Okay, so we're going to look at these two sides of this shape ABC because we want to find D. So always go from where the two sides come together. Okay, so what we're going to talk about first is I'm going to go from B to A. So I want you always to go from this point where the two sides come together. So I'm going to go from B to A, 1, 2 up, 1, 2, 3, 4 left. So I'm going to do the same thing from C, 1, 2 up, 1, 2, 3, 4 to the left. So that's where I think D is, and I'm going to verify that by using my other segment, okay? So now I'm going to use from B to C. Okay, so always go from B again. So you're going to go down 2, over 2. So down 2, left 2, right? So from A, we're going to do the same thing. Down 2, left 2. So there's our D. We got the same point both times. Y'all see that? And you can verify that by finishing the drawing if you wanted to, but D is going to be what point? -1, 0, okay? All right, for this next question, you need to draw it. That's all I'm going to say. It says you make 2 errands today. You leave your house and walk directly east. So I'm going from my house, and I'm going directly east to the grocery store. So I'm going directly east to the grocery store, and I went, it says east 5 blocks, right? So read, draw, okay? Then you go directly south to the post office. Okay, so I went directly south to the post office. And then it says from there, you walk back home 13 miles. So I went from the post office to the home 13 miles. So what kind of triangle is this, y'all? Yep, it's a right triangle. And so we can use that formula, A squared plus B squared equals C squared. And what is C always? It's the hypotenuse. And the hypotenuse is opposite the right angle. So we're going to put our 13 squared here. And we're looking for this from the grocery store to the P.O. box, right? Isn't that what it says? How far is the grocery store from the P.O. post office box? Or post office? Okay. So I'm just going to put my 5 squared here plus my x squared and set that equal to 13 squared. 5 squared is 25. 13 squared is 169. Going to subtract the 25 from both sides. X squared, so 9 minus 5 is 4. 6 minus 2 is 4. So hopefully all of y'all know the square root of 144 is what? It's 12. Now look, we don't care about the negative 12 here, and the reason we don't care about the negative 12 here is because distance can't be negative. So this is 12 blocks is our answer. Got it? All right, so our last one here says, given the following pictures below, identify if it's a right triangle or not. If it's a right triangle, which two lines create the right angle? Write a statement that proves it's a right triangle and tell where the right angle would be if it's a right triangle. Show your work on the drawing. Okay, so first of all, where do you guys guess that the right angle is going to be? Yep, I would say to A, because it looks like B and C are both acute angles, right? Okay, so let's just compare the two sides that make this. So we're going to look at BC and CA. BC and CA. Those are the sides we're going to look at, and we're going to find the slopes of them. Okay, so I want to go from B to A. Is that line rising or falling from left to right? You got it. It's negative, right? So we're going to put negative. I don't mean -1, but so we're going down 1. That's my rise, right? And over 1, 2, 3, 4. So remember, we're doing rise over run, right? So this is -1/4, okay? Now let's talk about this other side right here. CA. Okay, so again, we're going to talk, is it rising or falling from left to right? It's rising, so it's going to be positive. So how far? 1, 2, 3, 4 up, or 3 up, sorry, 3 up, and how far? Over 1, right? So that's our 3. So is there any relationship between that -1/4 and that 3? No, so this is not a right triangle, right? Okay, now let's go down here to B. Again, let's make a prediction. Where do we think the right angle would be? I would say, again, it's C, right? So, again, we're going to go CB. We're going to find that, and we're going to find CA. So let's just start with CB. CB, is that line rising or falling from left to right? It's rising, so it's going to be positive. So we're going to go up 1, 2, 3, 4, 5, 6. That's my rise over my run, which is 1. So that's 6, okay? Now we're going to talk about CA. Now is that line rising or falling from left to right? It's falling. So we're going to count, it goes down 1. So this is our run, right here, right? Isn't that our run? So that's our rise. So that's 1. And our run is 1, 2, 3, 4, 5, 6. See that? So what is the relationship between these two slopes? They're perpendicular, right? Because they change sign and they flip, okay? So we're going to say CB is perpendicular to CA. Yes, this is a right triangle. And where do we think our right angle is? The right angle is at C.